This is the Human Benchmark website, a collection of tests to evaluate different skills such as memory, reaction speed, and typing. I'm pretty average when it comes to my scores on all these tests, but since I'm a programmer, I'm able to satisfy my ego through the powers of JavaScript. First on the chopping block is the reaction time test. This test is simple enough. Click when the box lights up green. My reaction speed falls right at the top of the curve here, but let's change that. Opening up the developer tools, I can see how this test works. The main div has the class name viewGo when it's green, viewResult after it's clicked, and viewWaiting when it's red. We can make use of this class name with the query selector and create our own click events programmatically. To test this out, let's initialize a new mouse event of type mouse down, as that's what triggers the click event for this test. Next, we have to select the div that we want to dispatch the event to, in this case using the getElementsByClassName method, and dispatch the event. And there we have it, a program click that works with the test. In order to click as soon as we possibly can, I'll wrap this code in a set interval block that will check every millisecond for the viewGo class and click as soon as it pops up. Just like that, we've conquered the reaction speed test. Time of 3 milliseconds solidifies us in the 100th percentile with ease. 3 milliseconds seems a bit slow though. Maybe I can optimize this a bit. Instead of traversing the DOM every iteration of setTimeout to find the div, I'm going to store the element before the loop starts. This way I only have to check the element's classes each iteration, which should be much faster. I'm also going to initialize the mouse down event once outside the loop. Let's see how well this does. Well, can't do much better than this. I'm satisfied with this for now. Let's move on. Another interesting test we can break is the typing test. I'm not even going to try to complete this. Let's just open up the DevTools right away. We can see each letter is wrapped in a span with class incomplete to start. We can use the same class name selector to build out the array of letters we need to create keyboard events for. Since this one is looking to be a bit more involved, let's open up a code editor to build out our script. First off, I'm going to loop through each letter and create a new key down event, setting the key to the character we want to type. Then we just need to dispatch the keyboard event onto the parent div, which is the one with the event listener. I'm going to go ahead and paste that in here, and it looks like we have 11,000 words per minute. That's pretty good. I'll just try it one more time just to be sure. For the first optimization, let's do something similar to the reaction test by storing the parent div into a variable, eliminating the need to search for it on every iteration of the loop. And we're seeing slightly better results here, not bad. We can make this even faster by storing the letters into an array even before we start looping. This loops through the letters themselves instead of the HTML elements and removes the needs for the inner text call each time. Trying this new way, we instantly see that this is our best improvement yet. It more than doubles our words per minute. But can we go even faster? Why should we have to create the events inside the loop when it's running when we can create all of them before we even start typing? This will remove practically all of the overhead work during the loop. Let's see how this one does. And yeah, it's even better. I'm also going to try a few different looping techniques other than for each. to compare the runtime optimization differences. Let's try this for of loop first. Not bad, seems around the same as the previous. And let's try this while loop. That's pretty good. I think, this score would probably secure us a spot in the top 100th percentile. I don't think I know anyone who can type over 35,000 words per minute. The name of the game for the aim train is to click the targets that pop up in random spots on the screen as quickly as possible. I'm a bit better at this than the reaction test, but I'm gonna wager that even I stand no chance against what's to come. I'm gonna first open the dev tools to find the class name of the target that I need to dispatch the click event to. And then like before, I'll initialize the mouse event and dispatch it on the target to click it. I'll again wrap this in a set timeout block so that it will run this script every millisecond. Running the script, we get 4 milliseconds to complete the whole target test, which is pretty good. It seems consistently capped at 4, however. Let's try to fix this. If I optimize the mouse event to be outside the interval like before, I still get the same result. So let's just do the age-old task of copy-pasting it over and over and over. And just like that, we have 1 millisecond. For the 4th test, we have the Chimp Test, where you're given a scattered grid of blocks with numbers on them that you have to click in order, which you have to memorize once the numbers are covered up. In the HTML, we can see that all the squares we need to click have the attribute data cell number, which contains the number that square is in the sequence. This makes it very easy for us to loop through. First, do a query selector for all elements with this data cell number attribute, then sort them by number to put them in the correct order. Loop through the cells and call the click method to fire it off. By running the script, we instantly clear this level. However, I want to automate the process of going to the next level as well. I'll complete a level and find the class selector for the continue button. Then I just need to add the level script followed by the continue button click, all in a set interval block to clear all 41 levels at once. Let's see you beat that, chimps. The next test we have is the verbal memory test. It's a pretty easy test that just gives you a word and you have to click whether you've seen it before or it's a new word. I'm going to open up the dev tools to get the class selectors for the word itself and the 2 buttons we're going to need to click. For this one, we're going to store all the words we get into an array. Let's get the current word, and if our array of words contains the word, we click the scene button. Otherwise, we'll go ahead and add the word to the array and click the new button. Since both buttons have the same class name selector, we can just index them with an array for 0 or 1 based on the button we want to click. For a potential performance upgrade, we can use a set instead of an array with the has and add functions instead, but speed isn't really necessary for this one. I'll go ahead and run this code, and then I'll speed it up for you so you don't have to sit around and wait for all of it. And about 40 seconds later, our score has reached over 10,000, which solidly setting us once again into the 100th percentile. After finishing these 5 tests, we have all the interesting ones out of the way. The remaining tests either take too long for an automated program to run or just aren't as interesting to optimize. So I'm going to take a look at these from a different angle. Instead of using JavaScript to beat the tests, we're going to modify the JavaScript of the web page itself using Chrome's local override feature. The first example of local override I'm going to do is for the visual memory test. First, in Firefox, I'm going to open up the inspector to view the event listener on these square elements. We can see that the onMouseDown event listener calls some method with clicked square in the main JavaScript chunk file for this page. Now back in Chrome, I'm going to navigate to the Sources tab and open the Overrides menu and select a local folder on my computer to store the overridden files. Going back to the page menu, I'll open up the main file and do a Control F for the clicked square string, which we see in this method here. I'm going to comment out some code here, and when I save it, it's saved in the local folder I had selected earlier. I'm also going to place a breakpoint in the code here so I can expect what's going on in this event. Once I refresh the page to make sure my changes are applied, I'll start the test. Clicking a square stops at the breakpoint I set, and we can inspect the value of variables. Looking into this E variable, we can see some interesting values in the stage, namely user answers and actual answers, which correspond to the grid of squares that I have clicked and I need to click to pass the stage respectively. In my local override, I'll set the user answers to the value of actual answers, which should make me complete the stage no matter where I click. About 60 stages later, I realized that, well, I can't actually lose. So let's open up my local override again and comment out the code that I made so I can lose and be able to submit my score. For the second of the less interesting trials, we have number memory, where it gives you a number and, well, you remember it. Seems trivial enough. Instead of setting our answer to the correct one like last time, I'm going to use local override to return my own block of code here. And I'll set our current level to 1000. And well, apparently the time it gives you to memorize the number is proportional to the length of the number, which I guess makes sense when you think about it. So I'm going to stop here for a bit. Alright, a couple minutes later, I have this number memorized, and it was 78. Oh, well, I guess reaching level 1001 will easily put us in the 100th percentile for the second to last time. Sequence memory is the last on our list, and it's so boring to show that I don't even want to. Instead, I noticed something interesting when submitting scores for a game. If you take a look at the Network tab of the Developer Tools, you can see the request the website makes to the Scores API with the fields Test ID and Score. Test ID seems to be related to the URL of the test, so I'll look and see the ID I want is sequence. Back in the Developer Tools, I'll right-click and select Copy as Fetch and paste this code into the Developer Console. All I need to do is edit the ID to sequence and fill out whatever score I want to give myself. In this case, let's go with 9,999,999 and hit enter. We can see on the Network tab that my new request was successfully sent and saved, so I'll just have to refresh the page and see that this is probably enough for a final 100th percentile. And with that, we've finished all of the tests. My challenge to you now is if you can come up with a code snippet that does consistently better than any of mine, particularly if you can get a faster completion of the typing test, since that's the one that can be optimized who knows how much faster. I'd love to see what you can come up with. I'll put a link in the description to my GitHub where I'll link all the code snippets that I've used in this video. Thanks for watching. And if you like this type of video, probably don't subscribe because I never make these. Maybe subscribe if you like Mario Kart.